All right, we're going to talk about volume of composite figures. Remember that composite figures are going to be figures that are combined of more than one figure. So here we're looking at three-dimensional figures. So we're going to go ahead with the formula. It's basically you're adding or you're subtracting the different formulas of, we'll call them we'll call them shape A and shape B. So you're going to be adding or subtracting depending on the situation. Let's take a look at this first one. First thing we want to do is we want to identify shape A and shape B. Well, shape A, so this one, there are several different ways. I mean, you could cut this across right here. You could cut it across right here. It does not matter. Okay, you just need to make sure you're doing your math correct. So let's say we cut it right here. We need to understand that this entire length is 12, and up here is just 8. So this is right here, this is going to be 8 inches now. This leftover is going to be 4 inches, so that way it makes an entire of 12. Okay, up here we need to see this is going to be 2. Same thing as here and here, because it's right here. All right, so we got 2. So these are some things we're going to need to look at. Shape A is going to end up being a rectangular prism. So we got a rectangular prism, and with the rectangular prism, the formula is area of base times height. Okay, so we're going to use this in a minute. The second one is also a rectangular prism. So we have 2 rectangular prisms. And so again, we have volume equals big B times little h. So let's take a look at the volume of figure A. So we're going to see V with a little subscript of A, meaning volume of figure A. We know that we've got our base and our height, so we need big B. So here it doesn't matter which one you use as figure A and B in this one or shape A and B, because they're both rectangular prisms. But if we go ahead and we take a look at this guy right here, with a rectangular prism, we need to remember it doesn't really matter which face you use as the base. But if I use this up here, if I use let's say we use this guy over here as our base, we're going to end up with 10 times 2. Because remember, all of these are going to end up being 2. So our big B is going to be base times height, 10 times our 2. So big B will wind up being 20. And we need little h, which height is going to be the other number we did not use yet, which is going to be that 4. Okay? We're technically just, volume of a rectangular prism is just multiplying all 3 numbers together. Okay? And that's what we're going to see here. So your volume of shape A will be the 20 times that 4. So the volume of A will be 80 inches, sorry, get that 0 in there, 80 inches cubed. Remember, we are dealing with volume. It's a little messy. I apologize about that. Let's take a look at shape B. So the volume of shape B, okay, if we take the base, we just make this one easy. We've got the base of 8 by 2. Ignoring this guy over here, we have 8 by 2. So big B would be 8 times 2, giving us 16. And then our height would be that 3, the other number we have not used. So height will be 3. So volume of shape B, we've got big B, 16, times height, 3, giving us its final volume, 48 inches cubed. So with this one, we are combining the 2 of them together. So over here, you're going to see me write V, and I know it says composite up here, but I always write the volume in my subscript. I always put T as total. So the total volume is going to be, we're going to have to take the volume of figure A or shape A, since we're combining them, plus the volume of shape B. So here, volume shape A was 80, plus shape B was the 48, making our total volume 128. So down here we have 128 inches cubed. Okay, it's just dividing them separately and adding or subtracting. So let's take a look at this next one. So our 2 shapes here, what do we have? All right. Figure 1, let's go ahead, shape 1, let's go ahead and go with this up here. We're going to have your triangular prism. Your triangular prism is going to just wind up being Same thing as your prism. You're going to have volume equals big BH. Okay. And then the second figure here, down here, is going to be a rectangular prism. Again, having volume being all your prisms are big B times little h, as big B can change. Okay, so let's take a look at our first shape here, shape A. So the volume of shape A, we need to remember that big B is going to end up being this triangle right here. Okay, the triangle is going to be the face. Right here is 23, meaning up here is also going to be 23. So we have our base and we have our height of our triangle for our big B. So we got everything there for us. We don't have to use Pythagorean theorem. So we have base of 23 times the height of the triangle 21 all over 2. This is going to wind up giving big B. I didn't put the big B there. Big B is going to be approximately round to the nearest 10, 241, well, just, yeah, 241.5. Your height is going to be, remember, the distance between the two triangles. So down here is 16, up here is 16 as well. So your height is going to wind up being 16. So volume of shape A, we have big B, which was 241.5, times little h, 16. Our final volume, once we multiply these together, is 3,864 inches cubed. All right, let's take a look at shape B. So the volume of B, big B, we have our base times our height. So we just use our 23 times our 16. Okay, we're ignoring this guy up here. 23 times 16. When we multiply these two together, we'll get 368. The height of the prism, the only number we have not used yet with rectangular prisms, is going to be that 18. So, volume of shape B, big B, 368. Okay, just following the formula down here, times the height of 18. This is going to wind up being 6,624 inches cubed. So again, we are combining these two together. So the total volumes, the volume of the total, is just going to wind up being the volume of A plus the volume of B. So we take A, which we found was 3,864. We're going to add the volume of B, which was 6,624, giving us a total volume of 10,488. So down here, 10,488. We're looking at inches for our units, and volume is cubed. All right, next. Go ahead and take a look at our two shapes here. We're going to go ahead and deal with figure A, or shape A. We can go ahead and we'll go with the cone that's on top up here. So we've got a cone. All right, we need to remember that a cone's formula for volume is going to be your pi r squared h over 3. And then shape 2 down here is going to be a hemisphere. And your hemisphere's volume is going to be 2/3 pi r. Remember, we are cubing on that one. All right. So we need the radius and height of the cone. So let's take a look here. With the cone, we do not have the height, we have the slant height. So we're going to have to use our Pythagorean theorem very quickly. All right, so here we have a squared plus the other leg, 6 squared, equals the hypotenuse, 10 squared. So square the two numbers. Then we're going to subtract that 36. A squared is going to equal 64. Square root, almost running out of room here. Your height is going to equal 8 for the cone. Okay? Please rewind if you need to. I know I'm fast. So, volume of shape A. We had our pi radius squared times height over 3. So here we have radius was our 6. Our height was that 8. So we have pi times our radius squared, 6 squared, times the height of 8, all over 3. Making sure we plug this in the calculator. If we wind up with a fraction, let's get it into a decimal. Actually, you know what? Let's just go ahead and do this in terms of pi. Since we're adding them, trust me, it'll just be easier here. We're going to keep it in terms of pi. Remember that 6 squared times 8 divided by 3. Do not plug that pi symbol in. We're going to wind up with 96 pi. We'll just leave it there for right now. All right, the volume of shape B. We've got our 2/3 pi r squared. So all we need in this formula is going to be that radius. So our r is going to equal, same thing, 6. So volume of shape B, we have 2/3 pi times a radius of 6. We are doing volume. We are cubing that without plugging in the pi symbol, leaving it in terms of pi. We're going to wind up with 144 pi. So again, these two will be combined. So your total volume is going to equal volume of A plus the volume of B. So we have 96 pi plus 144 pi, which in total, in terms of pi, you just add 96 plus 144, okay, and you're going to get 240, and then slap on that pi. So your volume will be 240 pi, or if we want to round, go ahead and put the pi symbol in and round to the nearest decimal, it actually comes out, winds up coming out as a whole number, 754. So we have 240 pi inches cubed. Pen's dying, let me grab another one. Or 754 inches cubed. There are our answers. Now the next one, we are taking away, yours should say shaded area, I believe, but we are going to take away, we want to remove that cylinder, so this is going to be a subtraction. Let's get through this pretty quickly. The first figure we're going to look at is going to be your rectangular prism. Remember, volume is big B, little h. The second one we are going to look at is going to be a cylinder. Remembering that the volume of a cylinder is simply going to be your pi r squared h. All right, so volume of shape A, the rectangular prism. Okay, ignore that cylinder in the middle. We're looking at big B, base times height, 20 times 16. So big B will end up being 320. Height is that 16, the one we did not use yet. So to find this volume, we simply multiply big B, 320, times the height of 16. And this volume will come out to 5,120. Now, let's take a look at that cylinder. So try to ignore everything else around it. For the volume of shape B, all we need here is going to be our radius and our height. Our radius is going to equal right here, that 5. Your height is going to be the distance between the two circles, between the two bases, which is that 20. So we'll go ahead and leave this in terms of pi for right now. We'll see what happens here in a minute. Volume of shape B is going to be the pi times your radius squared times height, leaving in terms of pi, 500 pi. Now we are removing the cylinder from the prism. So this time with the volume, the total volume, we are going to take the volume of A and we're actually going to subtract the volume of shape B. Okay, so we're going the other way, we're removing. So the volume of shape A, 5,120, we will subtract that 500 pi. And now when we plug in the calculator, we can just say 5,120 minus 500 pi symbol. Okay, that way it keeps us from having to deal with a decimal in this area. So then your total volume winds up rounded to the nearest tenth, 3,549.2. So down here at the bottom, adding in our units, 3,549.2. We are at inches, so inches cubed.